All right, I'm going to go section by section and just kind of see which ones you guys want me to work out, and I'll do those. And I'll pick a few too that I think are important, and we'll just kind of go through the review like that. So I want to take a look at number 3. What should I do first to factor number 3? Take out the GCF. What's our GCF? 3x squared. When we take out a 3x squared, we're left with x squared minus 144. Perfect. It's because he already did it. If you're not sure, just divide. 3 goes into 4 one time with 1 left over. 3 goes into 13 4 times with 1 left over. And 3 goes into 12 4 times. Can I factor x squared minus 144? The answer is yes. What's special about x squared and 144? Difference of squares. So x squared would break down into x and x. What are 2 factors of 144? 12 and 12. So x plus 12 and x minus 12. So this would be our answer. Now when it says factor, all you have to do is factor. There's no equal signs in the question. We don't need to put equal signs in any of our work anywhere. We're just factoring. All right, from the next section, 1 through 6, anyone specifically you guys want to see? Let's do 3. So when we're solving, these we're going to have to solve and factor, put it together. We're going to factor first and solve. We need it to be equal to 0 first. So I need to add 3y squared to move it to the other side. And we put it in standard form. So I have 3y to the 4th power minus 6y cubed plus 3y squared equals 0. What would we do next? Divide by 3y squared. So we're going to take out our GCF, which is 3y squared. When we take out the 3y squared, we're left with y squared minus 2y plus what? 1. Perfect. 3y squared divided by 3y squared is 1. Don't forget that 1. What are 2 factors of 1 that add to negative 2? Negative 1 and negative 1. So this would factor into what? Y minus 1 and y minus 1. And then we also have our GCF out front. Lots of people on the quiz forgot to write their GCF out front. And they missed that as part of their answer. Now here we're not just factoring, we need to solve. What would I do next? Set everything equal to 0. When there's equal signs in our question, we need to have y equals or x equals in our answers. So 3y squared equals 0, y minus 1 equals 0, and y minus 1 equals 0. Yeah, we're going to solve each one of these. So in the first one, I'm going to divide by 3. So y squared is equal to 0. And then we would take the square root, but the square root of 0 is still just 0. So y equals 0. The next one, how would I solve for y? Add 1 to move it to the other side, so y is equal to 1. And then the third one, same thing, add 1, so y is equal to 1. Now if your answer repeats, you don't have to list it twice, but it will help when graphing to list it as many times as you have. Yes. So this one was number 3. All right, let's do 5. So 3p cubed is equal to 21p. Perfect. We need it to be equal to 0 before we start solving. So let's move 21p to the other side. So I'm going to subtract 21p. So 3p cubed minus 21p is equal to 0. Now how would I factor here? Take out the GCF. What's our GCF? 3p. And then we're left with p squared minus 7. Can I factor p squared minus 7? No. 7's not a perfect square, so it doesn't factor anymore. So from here, we just set each one equal to 0. 3p equals 0. P squared minus 7 equals 0. The first one to solve, we're going to divide by 3. So p is equal to what? 0. Second one, I need to add 7 to both sides. So p squared is equal to 7. What would we do next to solve for p? Square root it. What do we have to remember when we take the square root of both sides? Plus or minus square root 7. So these would be our 3 answers. With p is equal to 0 and p is equal to plus or minus square root 7. So this one was number 5. So let's do a graphing one. Anyone specifically you guys want to see graphed? Sure. All right, let's do 9. I'm going to rewrite it down here so you have more room. X to the 5th power minus 2x to the 4th minus 15x cubed. All right, what should we do first? Take out the GCF. So we're solving just like we would normally. And then at the end, we're just going to put everything on the graph. So we still have to solve these just like the questions above. So my GCF is x cubed. When I take out an x cubed, I'm left with x squared minus 2x minus 15. Now, what are 2 factors of negative 15 that add to negative 2? Negative 5 and positive 3. So x minus 5 and x plus 3 equals 0. And we can't forget about the x cubed out front. What would we do next? Set each one equal to 0 and solve. So now we have 3 mini equations that we have to solve. X cubed is equal to 0, x minus 5 equals 0, and x plus 3 equals 0. So x cubed equals 0. Because it's x cubed, it's like saying x is equal to 0, x is equal to 0, and x is equal to 0. We have 3 of them. You don't have to put all 3, but it's important to know that you have 3 of them because it's going to help us with the graphing. Remember, we need to talk about multiplicity, which is how many we have of each. Then we also have x is equal to 5 and x is equal to negative 3. So let's put all 3 of those on the graph. We're going to have a point at 0, a point at negative 3, and a point at 5. So in addition to finding our zeros, there's 2 things that we need to find. We need to determine our end behavior. And we need to determine the multiplicity. So let's talk about our end behavior first. 5x to the 5th power, we look at our highest degree term. Is 5 even or odd? Odd. So does that mean that they go in the same direction or opposite directions? Opposite directions. Now we need to talk about whether it's positive or negative. Is it positive or negative? Positive. There's no minus sign out front, so it is positive. So what does that tell us that the right arrow does? Right arrow goes up if it's positive. What's the left arrow? Left arrow goes down. Think about it as it's positive, so it has positive slope. If I connected these 2 arrows in a line, my slope here would be increasing, positive. So we have positive slope. So I'm going to put those 2 arrows in my graph out of the point farthest to the right. I said my arrow goes up. What does the left arrow do? Go down. So out of my point farthest to the left, I have an arrow that goes down. Now we need to talk about multiplicity, so what we're going to do at each point. Then we need to talk about how many of each number we have. So if I have 3x is equal to 0s, is my multiplicity even or odd? If I have 3 of them, multiplicity would be odd because 3 is an odd number. We've got 3 of them. If I have odd multiplicity, do I touch and turn or go through? I go through. How many x is equal to 5s do I have? 1. So is my multiplicity even or odd? multiplicity would be odd. Do I touch and turn or go through? Go through. And then x is equal to -3. How many do we have? 1. So is my multiplicity even or odd? Do we touch and turn or go through when it's odd? Go through. So at each point, I'm going to go through the x-axis. We're going to cross at all the points. So we said at -3, we go through. We're going to make our way over to the next point, just like connecting the dots. What do we do at 0? Go through. Make our way over to the next point. What do we do at 5? We go through. So our graph should look like that. Now you only ever touch the x-axis at your zeros, at the solutions. So if your graph is off a little bit and you end up going like through and back through and something, it's just not going to work out. If whether your end behavior is wrong or your multiplicity is wrong, you're going to end up touching in more than one spot. So you always need to double check that you're only touching the x-axis at your zeros, at your solutions. Let's do 10. I'm going to rewrite it over here. So we have -3x cubed minus 15x squared minus 12x. All right, so first thing we want to do is solve. What would I need to do first to solve? Take out the GCF. What's our GCF? Perfect. -3x. We want to take out the -3, negative more specifically, because we like it when our leading term is positive. So -3x. We're left with x squared plus 5x plus 4. What are two factors of 4 that add to 5? 1 and 4. So this would break down into x plus 1 and x plus 4. Don't forget we took out that -3x out front. What would we do next? Equal them all to 0. Don't forget to set the GCF equal to 0 too. So -3x is equal to 0. X plus 1 is equal to 0. And x plus 4 is equal to 0. So when we solve the first one, we're going to divide by -3. So x is equal to 0. Next one, we're going to subtract 1. X is equal to -1. And then subtract 4. X is equal to -4. Yeah, your GCF will always be just 0. Because it'll be, well, not always, because remember, if our GCF was just a number, it goes away. Like if we didn't have an x, let's say our GCF was just 3, and we set 3 equal to 0. Does 3 equal 0? No, so it would go away. So only when there's an x in it, it ends up equaling 0. All right, so let's put points at 0, -1, and -4. All right, now two things that we need to talk about are the end behavior and multiplicity. Let's talk about our end behavior first. So our exponent, is it even or odd? So are they going to go in the same direction or opposite directions? Opposite directions, bless you. So it's negative, our leading coefficient's negative. What does that tell us about our right arrow? Right arrow goes down. We said that they go in opposite directions, so what does that mean our left arrow is going to do? Left arrow goes up. So let's put those on our graph. Out of the point farthest to the left, what did we say our left arrow does? Go up. Out of the point farthest to the right, what does our right arrow do? Go down. Now let's do our multiplicity. How many x is equal to zeros do I have? Just 1. So is my multiplicity even or odd? And if we have odd multiplicity, do we touch and turn or go through? Go through. How many x is equal to -1s do I have? 1. So is my multiplicity even or odd? Odd. We're going to touch and turn or go through when we have odd multiplicity? Go through. How many x is equal to negative 4s do I have? 1. So is my multiplicity even or odd? Multiplicity is odd because I only have one of them. If my multiplicity is odd, do I touch and turn or go through? Go through. So at each point, we're going to go through. At negative 4, we go through the x-axis. We're going to make our way over to negative 1, the next point. What do we do at negative 1? Go through the x-axis, make our way over to 0. What do we do at 0? Go through the x-axis. So our graph will look like this. So our graph only touches the x-axis at our solutions, at our zeros.
How do you determine whether it's like odd, opposite, or even the same?
So you look at the degree. So we're looking at the degree of the leading coefficient. I'll write that down for you guys just so you can have it. So for the end behavior. We're going to have 4 different cases. If it's an even exponent, so let's say we had x to the 4th power or negative x to the 4th power. Even exponent and positive, that means they're going to go in the same direction, so our arrows both go up. Negative and even exponent, they go in the same direction again, but because it's negative, they're both going to go down. If we have an odd exponent, so like x to the 3rd power or x to the 5th power, and it's positive, our right arrow goes up and the left one goes down because they go in opposite directions. And then if we have a negative x to the 3rd power or x to the 5th power, any odd exponent, when it's negative, the right arrow goes down and the left arrow goes up. So we're looking at the exponent. When it's an even exponent, they go in the same direction. When it's an odd exponent, they go in opposite directions. So you're looking at the exponent. So let's take a look at 13 first. So we need to think, are we missing any zeros? What are we missing? Negative square root 3. So anytime you have an I or a square root, remember it needs its partner. You need the conjugate pair. So it can't be complex without its buddy. So now that we found its partner, let's put them in factored form. So what would our first factor be? X minus 2. What would the next one be? X minus square root 3, and then the next one? X plus square root 3. All right, there's 2 different ways that we can multiply this out. We want to multiply the conjugates first, because you're going to get rid of the square root, or if you had i's, you're going to get rid of the i's when you multiply the complex conjugates together. I'm going to do both ways that we can multiply this out. So I'm just going to rewrite it up here because I'm going to show you both ways and you can solve it however you want. So because these are conjugates, we could do the shortcut, which is a squared minus b squared. What would our a be? X. We have x squared minus, what's our b? Square root 3 squared. So x squared is just x squared minus, what's square root 3 squared? The square root and the squared cancel, so it's just 3. So x squared minus 3. So this is one way on how to multiply these 2 together. We're going to come back and multiply the x minus 2, but I want to show you the other way that we can multiply those 2 together. So I'm going to do it up here. So if you don't remember the conjugate shortcut, or you're not super comfortable with it, you can always FOIL. So we start by multiplying our first. What's x times x? X squared. Then x times square root 3, we would just say square root 3x. X times negative square root 3 would be negative square root 3x. And then square root 3 times square root 3 would be what? 3. So minus 3. Now the middle terms are going to cancel because we have a square root 3x minus square root 3x, so they go away. And we're left with x squared minus 3. So there's two different ways you can multiply it out. You can do your conjugate shortcut like we did here, or you can FOIL. Either way works. Whatever you feel better with. Yes, now we still need to multiply the x minus 2 to it. So we're going to FOIL these two together. So what's x times x squared? X to the third power. X times negative 3. Then negative 2 times x squared. Negative 2x squared. And negative 2 times negative 3. 6. Last step, we want to put it in standard form. So x cubed minus 2x squared minus 3x plus 6. So that would be our answer. All right, while we're doing these, let's look at the bottom. So let's do number 12. We did 11 together. Make sure you read the directions for these. There will be some questions that say leave in factored form. So you don't multiply them out, you just leave it in factored form. So you have to find what zeros you have missing. Do I have any missing here?
Yes.
Which one? Awesome. We have negative 2i, so the partner to positive 2i. And then what's the other one? 1 plus I. Perfect. So we found our missing zeros. Let's put it in factored form. So what would the first one be? X plus 2i, then x minus 2i, then x minus 1 plus I, because we flipped both the signs, and then the other one, x minus 1 minus I. Don't forget the x's. That's a common mistake that people will make, is when they see that they have two terms, they somehow just forget that they need an x. You always need an x in each factored part. All right, let's take a look above. Let's do 1 through 4 real quick. So here we're just identifying the number of solutions. So for number 2, how many solutions would we have? 3, because our exponent is 3. Number 3, how many solutions would we have? 5, because our highest exponent is 5. And then number 4? 6. Perfect. One or two? And I hope nobody gets it wrong. All right, let's look at number 6. Let's find all the zeros. Actually, I want to do 5 and 6. Let's do 5 first. So 5 factors, but it's a little bit different. What are 2 factors of negative 36 that add to 5? Negative 9 and 4. Perfect. So this is going to factor into, we have a minus 9 and a positive 4. But what's going to go in the first spot? X squared, because it starts with x to the 4th power. So this is going to break down into x squared and x squared. So we have x squared minus 9 and x squared plus 4. Can x squared minus 9 be factored anymore? Into what? X plus 3, x minus 3. Can x squared plus 4 be factored anymore? No, why not? It's not the difference of squares. It has a plus sign, so it's not the difference. So this would just be x squared plus 4. Now we are solving. We need to find all the zeros. So what should we do next? Set each one equal to 0. So x plus 3 equals 0. X minus 3 equals 0. X squared plus 4 equals 0. So in the first one, we get x is equal to negative 3. X is equal to positive 3. How would we solve the third one? Subtract 4. So x squared is equal to negative 4. Then what? Square root both sides. So what does x equal? plus or minus, because we took the square root of both sides, you need the plus or minus, 2i. Awesome, because the negative comes out, turns into an I, and the square root of 4 is 2. So these would be our 4 answers that we have. We have -3, +3, +2i, and -2i. But you can leave it as plus or minus on the quiz or test. That's fine. Any questions here? Good with this one? All right, let's do 6. Can we factor number 6? No. So what do we need to do if it doesn't factor? Last over first. So what are factors of the last term? So you have plus or minus 3, 2, 1, and 6. And then factors of our first are just 1. So inside the box, make sure you're not missing any terms. We have x to the 4th power, 3rd power, 2nd power, 1st power, no x. So we're good there. So in the box, we have 1, 1, -7, -1, and 6. What do you want to try first?
3.
Sure, let's try 3. Drop down the 1, multiply, add, we get 4, 12, 5, 15. Is 3 going to work?
No.
No. Didn't you guys do this for homework? Shouldn't you know what works?
Try 1.
Let's try 1. 1, this would be 2, 2, -5, -5, -6, -6. Does 1 work? Yes. So x is equal to 1. That's one of our answers. How many answers total are we going to have here? 4. So I did last over first. It was x to the 4th power. What is it now? X to the 3rd power. So x to the 3rd power. Will it factor being x to the 3rd power? No. So let's do last over first again. So we have 1, 2, -5, and -6. So a lot of people on the quiz were like, I don't know what I do from here. You just either factor this or do last over first again. So it goes in the box. Let's try -1. -1 would be 1, -1, -6, +6. Does -1 work? Yep, let's add that to the list, -1. So we had x to the 3rd power. What's this one going to be now? X squared. Can I factor it with an x squared? Yes. You want to keep doing last over first until you get to x squared. Then just factor it from here. Andrew, paying attention?
Yes.
So what are 2 factors of -6 that add to 1? 3 and -2. Yes. You can, but then you'll end up with like 2 numbers, so you just have to remember to set that equal to 0 when you're done. Like when you get to just 2. So here we have x plus 3 and x minus 2. So what's x going to equal? -3 and +2. So if we would have tried -3 or +2 from the start, those would have also worked. -3 and +2. So these are our 4 answers. Sometimes it also might work out where it's not a real number. So anytime you get to x squared, you just want to factor it because you might have to, like you might end up getting an I, which wouldn't work with synthetic division. Any questions here?